Good morning. Today we discuss a new chapter, partial fraction and integration of rational functions. Before we start this chapter, we should know about polynomials, degree of polynomials, partial fraction, rational function, proper algebraic fraction, improper algebraic fraction. Okay. First, polynomials. A sum of multiples of integral powers of a variable is called polynomial. A sum of multiples of integral powers of a variable is called a polynomial. The polynomial function in the variable x is given by p of x is equal to a0 plus a1x plus a2x square plus a n minus 1 x to the power n minus 1 plus a n x to the power n, where a0, a1, a2 up to n belongs to real number. So now we take an example of a polynomial. P of x is equal to x cube plus 2x square plus 3x plus 1. It is a polynomial. Okay. Degree of a polynomial. Degree of a polynomial. The highest power of a term in a polynomial is called degree of the polynomial. So the highest power term present in a polynomial is called the degree of that polynomial, or the highest power of a term in a polynomial is called the degree of the polynomial. So here p of x is equal to x square minus 2x plus 3 is a polynomial and its degree is 2 because its highest power term is x square. So the degree of this polynomial is 2. If we write it, p of x is equal to p of x is equal to 2x plus 3. So the degree of this polynomial is the degree of this polynomial is 1 because the highest power term is 2x, the power of x is 1. Similarly, if we write p of x is equal to 2, it is the polynomial which is a constant, so its degree is 0. So degree of this polynomial, is 0. Okay, here the polynomial is a constant. The polynomial is a constant. Now we know about partial fraction. A sum of fraction that is equal to a particular fraction is called partial fraction. Okay, a sum of fraction which is equal to a particular fraction that is equal to a particular fraction is called a partial fraction. Partial that is equal to a particular fraction, that is something. Okay, for example 1 by 2 plus 1 by 4 that equal to 3 by 4. You know that 1 by 4 is one of the partial fraction of 3 by 4. 1 by 4 is one of the partial fraction of 3 by 4. If we add 1 by 2 and 1 by 4, that is equal to a particular fraction 3 by 4. Okay, so a sum of fraction that is equal to a particular fraction is called a partial fraction. Okay, next, rational function. A function of the form a function of the form p of x by q of x, where p of x and q of x are polynomials, is called a rational function. Is called a rational function. Is called a rational function. Okay. For example, 4x minus 9 divided by x square minus 5x plus 6 is a rational function, because 4x minus 9 is a polynomial of degree 1, x square minus 5x plus 6 is a polynomial of degree 2. Okay. Next, another example, x to the power 4 plus 3x cube plus 2 plus x square minus 1 whole divided by x cube plus x square minus x minus 1 is another rational function, because the numerator x to the power 4 3x cube plus x square minus 1 is a polynomial of degree 4, and the denominator x cube plus x square minus x minus 1 is a polynomial of degree 3. Okay. Next, rational function is of two types. 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 One is proper algebraic fraction, and the other is improper algebraic fraction. One is proper algebraic fraction and other is improper algebraic fraction. First we know proper algebraic fraction. Okay. What is called proper algebraic fraction? In the rational function, p of x by q of x, in the rational function p of x by q of x, if the degree of p of x, if the degree of p of x is less than the degree of q of x, then it is called proper algebraic fraction. Then it is called proper algebraic fraction. Then it is called proper algebraic fraction. Okay. If the degree of p of x, that means in the rational function, if the degree of a numerator is less than the degree of a denominator, that is called a proper algebraic fraction. That we write the example 4x minus 9 rational function. What we are taking 4x minus 9 divided by x square minus 5x plus 6. X square minus 5x plus 6 is a proper algebraic fraction. Proper algebraic fraction, because the degree of 4x minus 9 is 1 and the degree of x square minus 5x plus 6 is 2. That is, the degree of a numerator is less than the degree of a denominator. So it is called proper algebraic fraction. Next, we write a improper algebraic fraction. Improper algebraic fraction. In the rational function p of x by q of x, if the degree of a p of x is not less than the degree of a q of x, then it is called improper algebraic fraction. Improper algebraic fraction. For example, improper algebraic fraction, for example, x to the power 4 plus 3x cube plus x square minus 1 divided by x cube plus x square minus x minus 1 is an improper algebraic fraction. Okay, because the degree of numerator is 4 and the degree of a denominator is 3. So the degree of a p of x or numerator is not less than the degree of a denominator q of x. That is called improper algebraic fraction. If the rational function is in the form of improper algebraic fraction, then we divide it and write it as the sum of a polynomial and a proper algebraic fraction. Sum of a polynomial and proper algebraic fraction. Okay, if the rational function p of x by q of x, if the rational function p of x by q of x is an improper algebraic fraction, then we can write it as p of x by q of x is equal to phi of x plus r of x divided by q of x. Okay, where phi of x is a polynomial and r of x by q of x is a proper algebraic fraction. Okay, that is, we get it by dividing p of x by q of x. That the remainder is r of x and the question is phi of x. Okay, that is, now we take an example that already we know. Example, x to the power 4 plus x cube plus 3x cube plus x square plus 1 plus x square minus 1, sorry, minus 1 divided by x cube plus x square minus x minus 1 minus 1. That it is an improper algebraic fraction because the degree of a numerator is 4 and the degree of a denominator is 3. So degree of a numerator greater than the degree of a denominator. So it is an improper algebraic fraction. Now we make it as the sum of a polynomial and a proper algebraic fraction. Okay. Now we divide x to the power 4, that is x to the power 4 plus 3x cube plus x square minus 1, that is x cube plus x square minus x minus 1, that we write x, so we get x to the power 4 plus x cube minus x square minus x, that is minus plus plus, so we get a 2x cube plus 2x square plus x minus 1, that plus 2, so we get 2x cube plus 2x square minus 2x minus 2, that is minus plus plus, so we get a 3x cube 3x plus 1. Okay, so we write it as x plus 2 plus 3x plus 1 divided by x cube plus x square minus x minus 1. Okay, that x plus 2 is a polynomial of degree 1 and 3x plus 1 by x cube plus x square minus x minus 1 is a proper algebraic fraction because the degree of a numerator is 1 and degree of a denominator is 3. So the degree of a numerator is less than the degree of a denominator. Okay, that is, since the integration of a polynomial is quite easy, so we have to discuss only about the integration of a proper algebraic fraction. We should discuss only the integration of proper algebraic fraction. Okay. First, we divide the proper algebraic fraction into different partial fraction. Simple fraction called a partial fraction. Okay. That depends upon the denominator q over x. So there are four different cases. First, we integrate the polynomial, that is quite easy and we can integrate it. Next is the proper algebraic fraction. We integrate it. Before we integrate it, first we divide into simple fraction. Okay, simple fraction, that is called partial fraction. Okay, so there are four different cases depending on the fraction of the denominator q over x. There are four different cases arise. There are four different cases arise depending on the denominator, depending on the fraction of the denominator q of x. fraction of the denominator q over x. Okay, case 1. First case, that is the partial fraction corresponding to non-repeated linear factor. The partial fraction corresponding to every non-repeated linear factor ax plus b of q of x is of the form a by ax plus b, where ax plus b is a linear factor and capital A is a constant. Okay, suppose if q of x is of the form a1x plus b1 whole into a2x plus b2 whole into a3x plus b3. All factors are non-repeated: a1x plus b1, a2x plus b2, a3x plus b3. Then the proper algebraic fraction r of x by q of x can be written as the sum of a partial fraction of a1 by a1x plus b1 plus a2 by a2x plus b2 plus a3 by a3x plus b3. Okay, if q of x is in the form this form, so we write r of x by q of x as a1 by a1x plus b1, a2 by a2x plus b2 plus a3 by a3x plus b3. If the partial fraction corresponding to repeated linear factor, then we write it. If the partial fraction corresponding to repeated linear factor ax plus b whole to the power r, ax plus b whole to the power r, then of q of x is of the form ar suffix r by ax plus b whole to the power r, where r is equal to 1 2 to n. Okay, suppose if q of x, that is case 2, if q of x is of the form ax plus b whole square whole into cx plus d, then we write the r of x by q of x as ax as a1 by ax plus b, a2 by ax plus b whole square plus a3 by cx plus d. Okay, that is it. The partial fraction expressed as the denominator q of x as repeated linear factor. Okay, that next case 3, the partial fraction corresponding to non-repeated quadratic factor. The partial fraction case 3 corresponding to non-repeated the partial fraction corresponding to non-repeated quadratic factor lx square plus px plus q, lx square plus px plus q of q of x each of the form a1x plus b1 or ax plus b, whatever, lx square plus px plus q, a1x plus b or a1x plus b1 divided by lx square plus bx plus q. So the q of x is in the form lx square plus px plus q whole into ax plus b. Then we write r of x by q of x as a1x plus b1 divided by quadratic factor lx square plus px plus q plus a2 by ax plus b. Okay. If the partial fraction is 4, the partial fraction corresponding to repeated quadratic factor lx square plus px plus q whole to the power of q of x is of the form ar x plus br whole into lx square plus px plus q whole to the power r, where r is equal to 1, 2 up to n. So if q of x is equal to lx square plus px plus q whole square whole into x plus b, then we write it r of x by q of x as a1x plus b1 by lx square plus px plus q and a2x plus b2 divided by lx square plus px plus q whole square plus a3 by ax plus b, a3 by ax plus b. Okay. So now we should know how we can find the constant a1, b1, a2, b2 and a3, etc. Okay. There are two methods to find the value of the constants, to find the value of the constants, we use two methods. Okay, we use two methods. First, method 1, to find the value of the constants, both sides of the rational function or proper fraction multiplied by q of x, that is called clearing the fraction. To find the value of the constants, both sides are multiplied, both sides of r of x by both sides are multiplied by q of x, that is called clearing the fraction. Okay, thereby clearing the fraction, clearing the fraction and the coefficient of like powers of x on both sides, coefficient of like powers of x on both sides are equated. Coefficient of like powers of x on both sides are equated. These results as many equations as the number of constant. This results as many equations as the number of constant to be determined. And can be solved to determine the constant, and can be solved to determine the constants. Okay, constants. Next, in this method, first we multiply q of x on both sides of the proper algebraic fraction. There, that is called clearing the fraction. Then we equated coefficient of like powers of x. Here we take the variable is x. Like powers of x on both sides. This results as many as equation as the number of constant to be determined. Okay. Second method 2. To find the values of the constant, both sides are multiplied by q of x, same thing, thereby clearing the fraction, and any suitable particular value of x, and any suitable particular value can be given to x, on both sides, to get an equation involving the constant. Can be given to x on both sides to get an equation involving the constants. Okay. This process can be repeated. This can be repeated by taking different values of x. This can be repeated by taking different values of x. Different values of x. This can be repeated by taking different values of x to get as many equations as the number of constant to determine, or as necessary to solve and determine the constant. this results, okay, by taking different values of x to get as many equations as necessary to solve, and determine the constants okay. You can use in one problem, you can use two methods to find the value of the constant. Okay, here we take an example where we use both the method 1 and method 2 to find the value of the constant. Okay, now take an example from your exercise 9F number 1 triple I. Example exercise 9F 1 triple I. Okay, integrate 5x minus 12 divided by 2x minus 3 whole into x minus 6 dx. Okay, answer. Now that the integrand is a proper algebraic fraction, because the degree of numerator 5x minus 12 is 1 and the degree of denominator, that is the product of 2x minus 3 and x minus 6, is in 2. So it is a proper algebraic fraction because the degree of numerator is less than the degree of denominator. That the denominator q of x, in place of q of x, here 2x minus 3 whole into x minus 6, that is the non-repeated linear factor. That is called linear factor. Because the degree is 1, first power term is 1. So first we write let 5x minus 12 by 2x minus 3 whole into x minus 6, that is equal to the sum of a by 2x minus 3 plus b by x minus 6 1. Here you know that the denominator q of x is the non-repeated linear factor. So we write it as in the form constant by 1 factor plus a constant by 1 factor. So now we multiply q of x on both sides. That is called clearing the fraction. Okay. Then we get 5x minus 12, that equal to a whole into x minus 6 plus b whole into 2x minus 3. Okay, number 2 equation. Now here we use the method to find the constants, value of the constants a, capital A and capital B. First we use method 1. Okay. Now we equated the coefficient of like powers of x, equating the coefficient of like powers of x on both sides of equation 2, we get that here the coefficient of x in the left side is 5 and on the right hand side is after simplification we get a plus 2b. A plus 2b. That means a plus 2b is equal to 5. That is 3. Okay. Next we use second method. Okay. Put x is equal to 6 in equation 2. Then that the term a whole into x minus 6 vanishes. That means that becomes 0. So we get directly the value of b. Put x is equal to 6 in equation. Put x is equal to 6 in equation 2. We get 5 into 6 minus 12 is equal to a whole into 6 minus 6, that plus b whole into 2 into 6 minus 3. That means 30 minus 12 is equal to 0 plus b whole into 12 minus 3. That means 18 is equal to 9b. That imply 9b is equal to 18 and b is equal to 2. B is equal to 2. Put b is equal to 2 in equation 3. We get a plus 2 into 2 is equal to 5. A plus 4 is equal to 5. That means a is equal to 5 minus 4, that equal to 1. So we get the value of the constant as a is equal to 1 and b is equal to 2. Now we put a is equal to 1 and b is equal to 2. A is equal to 1 and b is equal to 2 in equation 1. In equation 1 we get 5x minus 12 divided by 2x minus 3 whole into x minus 6, that equal to 1 by 2x minus 3 plus 2 by x minus 6. Now integrating both sides. Okay, integrating both sides, we get a integral 5x minus 12 divided by 2x minus 3 whole into x minus 6 dx, integral 1 by 2x minus 3 dx plus integral 2 by x minus 6 dx, that equal to 1 by 2 ln 2x minus 3 mod plus 2 integral dx by x minus 6, that equal dx by ax plus b is 1 by ln ax plus b. So here 1 by 2 ln 2x by 2 ln 2x minus 3 mod plus 2 ln x minus 6 mod plus c, that equal to ln 2x minus 3 whole to the power half plus ln x minus 6 square plus c, that equal to ln m plus ln mn. So we write ln of 2x minus 3 whole to the power half whole into x minus 6 square plus c. Okay, that also we write ln 2x minus 3 root x minus 6 square plus c. Okay, thank you.